Hi, it's Carly McAvoy. I wanted to give you some practice with the sampling distribution of means. Let me collapse this ribbon to make it a little bit nicer. We're going to be starting with a population that is not normally distributed. So in the last example it was, and this one it's not. That makes it very different. Restaurant bills at a given restaurant have an assumed population mean of $32.40 and a population standard deviation of $8.16. This data is heavily skewed to the left. Just wanted to show you a picture of what that means. Left skewed means that you have a tail going off to the left. It also means that your mean is going to be less than your median, which is less than the mode. And so anyway, those things matter because when we're talking about using this information to find percentages, we anticipate that we're going to have a normal distribution, and this one is not normal. Explain why you cannot determine that a given bill will be at least $35. We're talking about one bill, and if we're talking about one, we would use the population data, but the population data is coming from something that's not normal. So we can't do it because we can't find probabilities with skewed distributions. What if we had 5 bills? Can you estimate the probability that the next 5 bills will average at least $35? Well, let's look at all the things we need for the central limit theorem. We need independence, and if this is 5 different people that came in to eat, we would say yes. Not glucose levels, but the bills are independent. This is from another last video, obviously. And then we want to know, are they random? We assume that they're random, even though in this particular example, not terribly random when you think about the fact that they're coming from the next 5 bills in a row. That could be all during dinner time when they're going to be higher, or all during lunch when they're going to be lower. So it's not great, but we're going to assume that. And the last thing is the sample size. N equals 5 is small, and the population is not normally distributed. So that means that it's too small, and we can't calculate this probability. We really want to have an N that is greater than 30 or more. So the next thing is, if we take the average of the next 50 bills, would all the conditions be met? Well, we just saw that all the conditions were met except sample size. 50 is more than 30, so yes. So it says define the model with its parameters and draw and label it. Remember, when we're talking about a distribution of the means, we want to talk about the mean as the same as the mean as the population. So our population mean is 3240. That's what we're going to have for that. But we always have to change our standard deviation. For the standard deviation for the distribution of the means is going to be the population standard deviation divided by our N, or the number of items that we're looking at. The standard deviation was given as $8.16, and we have a population of 50, and doing that calculation we get 1.154. And we could draw a picture of that. I did it in GeoGebra, but here's what we're looking at. I just did 50% to show you if we were looking at $32.40, which is our average, we would have 50% of our values would be less than that, and 50% of our values would be more than that. That's just kind of what we should get a feel for that. 50% means the halfway point, and that mean being 32.4, that's right where we are. Okay. How likely is it that the next 50 bills have an average of at least $35? So we would use GeoGebra to do that. I would, and I would be looking at what's the probability that we could get greater than $35 on the next 50 bills. And look at the probability that I got for that. It's very small, because if you have 50 people come in, you're probably going to get right about on the average. We can take a look at that in GeoGebra. I don't think I have it on the right screen. Let's see if I can bring it over. Here we go. In this case, we're looking at 32.4 as our mean, and our standard deviation was 1.154, and we're talking about what are the chances that it's greater than. So when you do that, you want to make sure you're clicking on this right hand side, greater than $35, and that's how we got that picture. So we have other videos that are explaining how to use GeoGebra, so I will be doing that less and less, but that's how we're doing that. And so that's a really small percentage. What does that actually mean? It means that we have a 1.21% chance of the next 50 bills will average at least $35. So for the most part, they're probably going to come in pretty close to the actual average for the population. But we have a small percentage of a chance that they would average greater than that. All right, that's all for this lesson, and I will see you next time. Have a fantastic day.